So at one point, I actually sat down and anybody ever used Tinkercad before? Tinkercad can make electronic circuits and 3D, like for 3D printers. You use this to design whatever you want to 3D print if that's what you want to do. But my son actually came home with this. They played around with it in junior high. I was like, this is so cool because you can make shapes to scale and actually visualize them, be able to look at it from all angles. So this was the one question on page 20. Some of you had a hard time visualizing like the inside rectangles. And so I don't know if I guess we could zoom further in, can we? No. Maybe not. Does that go even further though? Yeah? Doesn't. Interesting. I remember being able to like actually go into that. Oops, don't want to move it. But anyways, I think it's pretty cool. And so this is what you should have envisioned when you worked on that one. Then there's the other one with the well or the cistern that is being built. That's this one here. I think my iPad is not. Or is it the program today? Oh, there we go. Let's see, right? So it had like 1 meter thick walls, right? It was a 1 meter, 1 foot. I can remember exactly how thick. So that's what you want to kind of envision. And the same thing is at the ground, right? Can you see that there? Even the ground, you have that 1 foot thickness all around, right? So that's kind of what I wanted you to envision there. This is on page 21, I believe. And then there was the lunchbox. I think that one you probably were okay envisioning that one. I redid the key so that it actually is more in line to how I've been teaching it lately, not like 3, 4, 5 years ago. So if you want to give it a try, this is what I was envisioning. Okay. Another thing, I think before I give you the AC, I think I owe it to you to at least have one more shape in our notes. So before we do the AC, if you could go to page 20, we never ended up finishing that one. I have a feeling that quite a few of you have already, but it doesn't hurt, hearing the thought process again. I don't think it hurts. So we're just going to go for it, and if you're done all of it, just bear with us. We will get through it, okay? And then you prepare for the AC, right? So question 5 on page 20, some of you did it on the whiteboards, and I know that there were some frustrations, but that's part of learning. That's part of learning. If you can ace everything, anywhere you go, any class you go, it's too easy for you. Right? It's too easy for you. You should have some hiccups along the way. So here we go. We've got the dimensions of the rectangular solid, that is 5, 8, and 12. So we're just going to go 5, 8, and 12. Length, width, height. Extending from upper base to lower base is in the shape of a right triangular prism whose bases are equilateral triangles having edges of 3, having an edge of 3. So we know that, right, all around, this is 3 all around there. Determine the total exposed surface area. So even inside, right, the hole that you created exposes 3 sides inside of that solid, inside of that rectangular prism. So find the total surface area and the total volume. Let's do the total surface area first. So total surface area, I'm going to tell myself, what is it that I'm going to do? I'm going to find the surface area of the box, you can call it. And I'm going to subtract 2 triangles from it, the top and the bottom, because they're not there. It's just the shape is left, right? But you're not including that. Plus 3, if you want to call it, rectangles. That's how I solved it. I redid the key yesterday for you. So that's kind of how I go about it. I tell myself what is it that I'm going to do. And let's go and solve here. Surface area of the box is 2 times length times width plus 2 times length times height plus 2 times width times height. Always remember the brackets that have the heights, those are the walls, right? The thing surrounding this box. Minus 2 triangles. So I'm going to go 2, and I'm actually going to figure out the area of a triangle, right? So base times height divided by 2, like that. And then it's going to be plus 3 rectangles, and that's going to be, you have to be careful here, but I'm going to go length times width, and I know that it corresponds to the rectangles, right? I've told myself that, so you're not mixing up length width here with the length and width here, okay? Sometimes I use capital letters for the big shape and then lowercase for the smaller, whatever works for you. That's what you do, all right? So let's go and plug in what we know. 2 times length times width, that's 5 times 8, plus 2 times length times height, plus 2 times width times height, minus 2 times base times height divided by 2. And here we have to do a little bit of side work. Okay, so I'm going to take one of those triangles. We know that it's 3 all around, but we need to know the actual height right through it like this. It's equilateral, so we can split that in half, right? We can actually split it in half like this. We know that the slant here is 3. We know that if we split this in half, we get 1.5. And the height is something that I'm going to find out. That's one of the legs of the triangle, okay? So the leg will be the square root of the hypotenuse squared minus one of the other legs squared. Let me make some space here on the camera. There we go. And h is, for time's sake, I'm just going to have my, so you get root of 6.75. And if it's a decimal, I just go ahead and find out what that is using my calculator. That's 2.598 and something, right? So I'll just keep it there. And what are we in? Centimeters. Okay, don't forget your units. So this is an aside here. I needed the height of that one triangle, which I just found here. And the base of, you got to go back to the original triangle. The base is 3. So now you know 3 times height, which I just found, divided by 2. So let's go ahead and do that. 3 times 2.59 dot dot dot. That is very small. I apologize for that. Plus 3 rectangles. Where is that coming from? I think I have space to do that here. So I'm just going to cut it. And maybe I'll do it here. One of those rectangles, one of these rectangles that are here measures 3, because that's one of the sides of the triangle, and it's 12 centimeters tall because it goes from top to bottom right through. So that's what I'm talking about there. So this would be 3 times 12. Lots of numbers, very careful here. And now let's plug that in. I would have done it in steps. So I first do the box here, like this part gives me 392 minus, like this part right here. It's probably worth mentioning. If you miss it, it's not going to hurt you. But if you times it by 2 and divide it by 2, right, that expression, you really don't have to do that part. It's just really 3 times 2.598 repeat and something. And that is 7.794 dot 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 and then plus this last little piece here, which is 108. And here I'm ready to just subtract and add, and your calculator has the history, so just go back, copy, paste, and then you should get, which a number of you got yesterday, so that's good. This is the total surface, exposed surface area, right? That is always assumed that it's the exposed surfaces that you're calculating here. And that is it. Surface area is by far the hardest, by far the one you need to think really hard, like what am I including, what am I excluding? Do I subtract, do I add? Those kinds of things. Okay. Total volume. I'm just going to go volume of the box minus volume of the triangular prism. And here's where I didn't cover it, so it was okay that you didn't know what to do there. Okay, you didn't have a formula for this one. It's not a pyramid. It's not a pyramid, so don't go using the pyramid formula. It's here you just have to use the concept that I covered yesterday. And if you forgot, because life happens, this is the concept that I'm talking about. I'm just gonna go back in my notes here. You can't forget the hard prism. Right? You can't forget that one. But really, the volume of a shape is the area of the base times its height. So if you know the area of the base, just multiply it by the height. And so this is kind of what we're going to do, the area of the base, which you already know, times the height, the big height here on the outside. So here we go. Total volume. Volume of box is just length times width times height minus, this is base times height divided by 2 times, let's call that capital H. So this will be 5 times 8 times 12 minus, we already did this work earlier, so I'm just going to go base times height, so 3 times the height of the triangle we already know as well, divided by 2. So you got to be careful. Base times height divided by 2, this is the area of one of the base, and you're going to multiply it by the big height, which goes from top to bottom, which is 12, right? So that's where that comes in. And here you just have to be careful when you plug this in. 5 times 8 times 12. See here, it's 480. Minus, so you go 3 times 2.59, you copy this height, divide it by 2, hit enter, then you times that by 12, and you get 46.765 and then some, and that gives you 433.23, which a bunch of you, and this is centimeters cubed now. Okay, so total volume. Always clearly indicate your final answer. This is for the province as well. If you do a bunch of work and there's numbers all over the place, make sure you circle or clearly indicate your final answer to get the full marks. And don't go above and beyond of what they ask, because if you do make a mistake in doing so, I'm like, yeah, you know your stuff, right? But if you make a mistake, then we have to take marks off. We good? And so again, all this is, I redid the key exactly based on how yours looks. It's not kind of like the other one was a bit weird. So I decided to redo it. Okay, pause this. Right, so grab a pen or a marker to make corrections. Add as much as you want, as long as it's with a different color, right? So surface area and volume, what do you want to do first? It's up to you. You need the slant for surface area. So I might as well find that slant. That's the hypotenuse here. It would be 12 squared plus 5.6 squared, right? It would be adding the legs. So slant, I lost my, slant ends up being 13.2423 and something yards, right? If you have that, I'll give you a mark for that. Anywhere on the paper, if you have this, you get a mark. So surface area would be pi r squared plus pi rs. So that'd be pi. Radius is already given. We don't have to divide or anything. We're just going to square that, and then it's pi 5.6 slant, which we have there, 13.2423 and something. The surface area ends up being 98.52 something, and the other part is 232.971 and something. And here you go, this is the last step. 331.49 squared yards is the surface area. And for that piece, I would also give you a mark for this. So if you made a mistake on your slant, take away a mark, but then you still get the step mark for this. Yeah.
I got 231.45. That must have been because I rounded the slant to
2, yeah. So just take off half a mark at some point, and this it'll be RE, rounding early or rounding too soon. Yeah. All right, and then volume is just pi r squared times the height. So it's almost like the area of the base times height, but it's slant, it's caving in. So this will be divided by 3. So that's pi 5.6 squared times the height, which you already know, divided by 3. That ends up being 394.08 cubic yards. So make sure the units are there as well. You get a mark for that piece. So that's where the 3 marks are allotted. And now this is the one I'm curious to see how you did. So to find the surface area, how about I'll reserve this for volume, and I'll do the surface area down here. That's kind of, whenever you're trying to bank for or a lot space, that's your safest, is to give surface area the most. Yeah. Okay, that's right. I have volume on mine for some reason. It's just surface area. Yeah, perfect. I'll still use that space. All right. Surface area. So how would I approach this? As long as we get the same answer, we're good. Okay. So I would go surface area of large cylinder. That's how I'm going to approach it. So all of it plus lateral surface area of small. That's basically the quickest way of doing that. Because when you do the surface area, let's just do the formulas and then you'll see it. Right? This is 2 pi r squared plus 2 pi rh, so that'd be the large, plus just the 2 pi rh of the small one. How about I'm going to go capital R and capital H for the large one, and this is going to be 2 pi RH, all lowercase. Okay, so let me just do some math here. The diameter is 5.3, so radius is 2.6, there we go, yeah. And the radius of this is 1.8, so this is capital R, this is lowercase r, this is lowercase h, and this is capital H. Right, so here we go, 2 pi 2.65 squared plus 2 pi 2.65 times 5.5, I got this, right? Plus 2 pi 1.8 times 4.3. So let's see how this goes. I have to redo this because I did it slightly differently on the original. So bear with me. So it's 2 times pi times 2.65 squared. Oops. See the mistake there? 2 pi. So that's 44.123 something. And 2 times pi times 2.65 times 5.5. That's 91.577. And then it's 2 times pi times 1.8 times 4.3. That's 48.63 something. And if I add, you can't see that, sorry. If you add all three, oops, 184.33 is your total surface area. And so that would be in squared meters. Yep.
I got from the room, but I got 194.5.
194? Okay. I think I just rushed through it and just solved it. I'll explain why I did this. So when you do this one, you're actually finding, this is a good idea to highlight, I think so. You're finding everything here, all of this, and of course the bottom as well. That's what this does. But it also, it's almost like, you know, this little cap here, it's that finding the surface area of the large cylinder also takes care of that cap. Okay, so that's what this does. The small surface, the lateral surface area, this is just that, right? Without the circles, because I don't need to include either one, right? Because the top one is already included here, and the bottom one I wouldn't want to have anyways because it's not exposed. So this is kind of like the minimalist approach. I know you can do it a lot, like the formula can look a lot uglier, but you should still come up with the same answer. Okay, so my guess is if you were to subtract a small circle from your answer, you would get the same as me. So you just have that extra circle in there, extra small circle. So you'd have to, I would have to look at your formula, to be honest, to be able to answer that accurately. So if you're still scratching your head, I don't know how else to do it, to be honest. But one more time. And if you wanted to tune me out, just listen to some music or whatever. Right? So the large surface area, that takes care of all of this. I'm almost ignoring that this is sitting on top. So this piece is included here. And then I just need to add the outside, the wrap around, which is 2 pi RH of the small one. That's it. If you have any one of these small circles added here, you're going to be off at all, right? They shouldn't be on there at all. Okay, how are we going to mark this thing? Well, I don't think this is 5 marks. That would have been with the volume. So we're just going to go 3 marks, what I'm going to give you here. I think I forgot to add the volume because my original did have volume, but I didn't add it here, and I did tell you just to find a surface area. So let's just put it this way. If you forgot to omit that extra circle, then it's -1 to get 2 out of 3. Anything beyond that, I would give you at least 1 out of 3 today. For any work that you've done, you get 1 out of 3. And then anything in between, you give it half, 1.5 if you feel like you did more. We're not going to fight it today. It's just like I basically just wanted you to get through this and think about what needs to be done. All right? Yeah. Oh, for sure. I can do the rest. Yeah, actually, it's good exercise. So let's just this one would be at a 6, right? The back side. So we're just gonna say, just put a big mark out of 6. I'll go find it, and we can still fill in the front. Why not? Absolutely. So here we go. This is the front. Feet to centimeters. Um, I think 1 foot, is it 30, 48 centimeters? Okay, good. Cancel, cancel. Meters. But it's this many centimeters, right? Because 1 foot, I probably gave you 1 foot has 0.3048 meters, but that's the same as 30.48 centimeters. So if you did the intermediate step, 1 meter is 100 centimeters, it's fine. I have the key here, yeah. So this is 139,294 centimeters. Okay, that's the answer there. Meters to inches probably takes a little bit more work here. So what I did is I went 1 foot has 0.3048 meters, cancel, cancel. And then I used that 1 foot has 12 inches, cancel, cancel. And then when you multiply the top divided by the bottom, you get 19,685.04 inches. And now let's do these ones here. So I want you to almost think, right, you're going from feet to meters. Think of it that way. Okay, we know that 1 foot has 0.3048 meters, right? Once you've determined, hey, this is going to get me there, you need to match the units that are here. So we need to cube this entire thing. And really, you're cubing that because we know that 1 cubed is 1. Feet cubed is cubic feet, right? Like, it's just that top part. So I'd like to show that step. This is 1 cubic feet. And then just grab your calculator. 0.3048 to the power of, right? Use that hat button. And so this is 0.02, but don't round, cubic meters. Okay, I know it's weird, but if you take anything less than 1 and you square it or cube it, it's going to keep getting smaller. That's just how it goes. So now we can cancel, and so you just multiply. You basically take that answer, multiply it by 80, you get 2.27 rounded. 2.27 cubic meters. Okay. And this one, 34 kilometers squared. Think of what gets me from kilometers to yards. Did I give you that? I don't think I gave you anything there, did I? Okay, so you got to be creative. This is what I'm going to do. I'm going to go kilometers to miles. So I know that 1 mile has 1.6093 kilometers. And this is the kicker, you got to square it. You can't just do that. And how do I go from miles to yards? 1 mile has 1760 yards. You also have to square that one. So this is really ugly. So 34 kilometers squared. I'm going to go 1.6093 squared. 1 square mile is 2.5898 squared kilometers. That keeps going though. And then 1 squared mile, you go 1760, square that, you get 309,7600 squared yards. Some of you will probably come across this outside of high school, like converting like this, using this reasoning, depending on the field you go into. So you can cancel, 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 and you're left with squared yards. So you would go 34 times 1 times this, divided by this times 1, which is just that, really. So your final answer, that's a big number. Okay, 406,65885.18 squared yards. 40 million and then some squared yards. Okay, so to be honest, will you need to know this for the exam? Probably not, but I still think it doesn't hurt. The reasoning behind it, like what I'm doing, it's like, oh, I'm squaring. I'm taking what you normally did, and I'm just making sure I square everything. If this had been cubed, guess what? You would have had to cube everything. Would have been even a bigger number, right? So the reasoning is still very helpful. Okay. This one, I'm just going to give you the answers if you're interested. Surface area and volume. So surface area is 11,309.73 square inches, and the volume is 113,097.34 cubic inches, if you want to know what that is, if you want to try it later on. But it's really just using the formulas for surface area and volume, plugging it in, and then you go. Okay. All right. What I haven't been asking a whole lot of is going backwards. Like if I give you the volume of a sphere, what is the radius? Or if I give you the surface area, what is the radius? Like that, I still want you to be able to do. I just can't ask everything all the time. So we're going to